Hello, here we have problem 5 from chapter 22. Here is Millikan's experiment. He used an oil drop inside this chamber and suspended it when a downward electric field was applied. Find the charge on the drop in terms of E. So the first thing we should notice about this problem is that the oil drop is suspended. And there's forces to be considered here. So, first of all, there's a downward electric field, which isn't a force, but we can draw the vector here just for seeing it. And now, there should be a downwards force of gravity on this drop. We'll say up is positive, downwards negative. And on the other side of the drop, there should be an equal and opposite force, the electrostatic force. Now, let's write down the given values here in this equation. So the radius of the drop is equal to 1.87 micrometers, which is also equal to 1.87 times 10 to the negative 6 meters, or 1.87 times 10 to the negative 4th centimeters, because our density is in centimeters, and this will just be easier. So our density is equal to 0.879 grams per centimeter cubed. Now we can turn this into kilograms per centimeter cubed by multiplying it by 10 to the negative third, because there's 1,000 grams in a kilogram. So we'll end up getting 0.879 times 10 to the negative third kilograms per centimeter cubed. Now, the other things that we should write down is the magnitude of the electric field here. So, the magnitude of our electric field is 0.461 times 10 to the 5th newtons per coulomb. Now, our forces are equal and opposite in equal magnitude, opposite in direction, and we know our net force in the y direction is equal to 0, or in the only axis and direction that they're moving. So with that said, that means our Fg equals Fe, so our force of gravity is equal to our electrostatic force, which is really nice because now we can write a few things down. So our oil drop, if we were to zoom in really close on it at this oil drop, it would look like a sphere with volume equal to 4/3 pi r cubed. So our force of gravity is down, our electrostatic force is up, and our electric field is downwards. Because we know electric field is downwards and our force of gravity is downwards, and to keep the particle or oil drop suspended, the electrostatic force would have to be upwards. So, since the oil drop is moving in the opposite direction of the electric field, the charge on the oil drop is negative. So we can just write negative here. Then we don't have to deal with negatives, and we can just add on the negative at the end. We deal with magnitudes. So recall that the electric field is equal to the electrostatic force over the charge, or equal to electric constant times charge over r squared, and that our force of gravity is equal to mass times gravity. And since our density is equal to the mass times the volume, since we need the mass here in this force of gravity, we can rearrange this to get our density times the volume is equal to our mass. Now, since our force of gravity is equal to our electrostatic force, we can rewrite this E equation into the electric field equals the force of gravity over the charge. And rearranging that, you get the force of gravity over the magnitude of the electric field is equal to the charge. Now, in question here, it said find the charge on the drop in terms of E. So, E, recall E is the elementary charge, 1.6 times 10 to the negative 19th coulombs. And we need to find our charge divided by E. So that's going to equal the force of gravity over E. Since we need the mass in our force of gravity, because we're not given anything involving the mass, we can plug in PV here. So we get, it's not P, my bad, density, or rho, PVG over E. Now, to plug in these values, remember that our charge is negative. So we write negative 0.879 times 10 to the negative third, which is our density, times 4/3 pi times 1.87 times 10 to the negative fourth cubed, which is our volume, and then we times it by 9.81. Whoops. There we go. And then all over our magnitude of our electric field, which is 4.461 times 10 to the fifth times 1.6 times 10 to the negative 19th, which is our elementary charge. Now, if we plug into our calculators real quick, you end up getting it equal to negative 31.98 in the calculator, but since it's 3 sig figs in the whole problem, this is equal, 31.98 E. This is equal to negative 3.20 times 10 to the first E is the answer. And thank you for watching.